to give a quick demo of my computer vision final project for fall of 2019. My main file is this experiment file that goes through, takes in some arguments. It first calls a data reader, which reads the actual full image and cuts the numbers out of that. From there, the individual number labels are put on a black background and split and pre-processed so they can be used for training. The model that is used, there are three options here, that is taken in as a parameter, and the number of epochs, batch size, all of that is set in the individual functions that train each model. The models themselves are part of this separate file. You see we have my custom implementation of VGG16 here. We have the pre-trained version here, where the layers are not trainable. And then finally, we have the transfer learner. And for this one, I actually did set a few of the labels to not be trainable because I found that I received slightly better results by doing that. The learning rates and the decay are different for each model. Also in this file, there is the code to segment the video, which calls a function which uses MSER to segment each frame, so it works on the images as well. And then it uses suppression to make sure that, or non-maximal suppression to make sure that we don't have too many overlapping boxes and things like that. I did all of my training on GPUs on Floyd Hub. This is a not particularly good result, but I have lots of printouts using one-hot encoding. These are the probabilities of the different classes. I had 11 classes, and I was keeping track using these logs of which images had been already trained on. I have some statistics on this run right here, and this was a run of just regular old VGG16. I think this one had some weird parameters though. And I also will just demonstrate really quick when you do a run of my program, taking a second here, it will, I left in some of the extra boxes here, but this is my localization, and the CNN will actually check all of these boxes, and it's not too bad because there's only like 100 maximum, because most of the really bad ones get filtered out. But it's pretty good. The centers are marked with red, and centers are compared to like close centers, so a lot of boxes are eliminated that way as well. I actually haven't put the labels on this one so you can see a little bit better. And I left some of the extra boxes in too, but you can see some runs of it. Down of my overall pipeline, you start by reading data from files, which contain multiple images. You cut individual images out of those files. You pre-process those individual images, put them on a solid color background. Then you train on those cut out individual digits. Once your training is completed, you save your various models. You then go back, take a full image containing numbers. You run the image segmentation algorithm, in this case MSER, on it. You then filter the results, first based on aspect ratio to remove things that are very unlikely to be digits. Then to remove the remaining extra boxes that overlap and stuff like that, you can compare centers. That was a convenient way to remove extra boxes. Finally, on your 100 or so remaining boxes, which are likely to be digits, you run your CNN on those areas. And then finally, only where the CNN predicts that it is a digit, you draw the box on the image and print the label on the image to give you the final result. Box plus digit.